Okay, so let's try 5.2 number 28 just to boost our confidence. Hopefully this will actually boost our confidence and not crush it totally. So where do you start?
Solve homogeneous.
Yeah, okay, so you've got a homogeneous equation, right? So you would start normally with solving the homogeneous version. It's already that. Hooray. I don't have to find a particular solution. So I should convert to auxiliary. So I got r squared plus 3 is 0. Which you then solve. Good answer. So algebra gives you r is plus or minus the square root of 3. What do you do with that? Square root of negative 3, right? Shit. No, it's not that. So I get plus or minus the square root of 3 times I, right? Okay.
We can use Euler's to get sines and cosines.
Okay, so we use Euler's. This is purely imaginary, right? So I'm looking at e to the square root of 3ix, right? As my kind of fundamental object. And then I don't have to break off the real part and leave that out. I can just go straight to sines and cosines. So what do you get?
Cosine of root 3, or C1 cosine of root 3 plus C2 sine root.
Cool, so just this part is cosine of square root of 3x plus I sine of square root of 3x. Right? And then you could say, okay, so my two fundamental solutions are the real part and the imaginary part. So I'll pop those guys off, treat that as y1 and that as y2. So your y is going to be C1 cosine of square root of 3x plus C2 sine of square root of 3x. And then what?
We need to figure out how to shift it to get cosine and sine of zeros.
Yeah, so we could figure out how to shift it, or we could probably just plug in and deal. Personally, I'm just going to plug in and deal because I know how to calculate cosines and sines for pi's and root 3's maybe. Oh shit. You gonna see that? So if I try to just plug in, right, I'm going to get 2 is C1 cosine of pi over the square root of 3. Uh-oh. Right, plus C2 sine of pi over the square root of 3. Okay, and now I'm like, uh-oh, right? Because why?
Those are nice numbers that you can memorize.
Yeah, those are not standard angles, right? Should be, like, I'm hoping this thing lives in angle land in my head, and this does not live in angle land in my brain. It almost does, right? Like when it was a pi over 3, when I was having confidence just a second ago, and I was like, because I know how to calculate that, right?
And then you just crush your dreams.
But my dreams and hopes are crushed. But what the hell, like maybe it'll work out. So that's why, right?
He says.
I say hoping desperately.
You
So-
combine another equation?
Yeah, I need a second equation anyway, right? So where's the other equation come from? Y prime. Okay, so y prime then should be,
Minus.
it's a derivative of cosine?
Negative sine. So it's going to be negative root 3 C1 sine.
Hang on. Negative C1 sine of root 3x times root 3. Okay, oops. I don't know why I put more parentheses.
Plus
And then plus
root 3.
square root of 3,
C2.
C2, and then a cosine of the square root of 3x. Okay, and then I need to evaluate at pi over 3 again.
Yeah.
So I got negative 1 is going to be negative the square root of 3c1 times
Sine of pi over 3.
sine of pi over 3. And then we're going to have plus the square root of 3c2.
I think it's over root 3, isn't it?
Oh, thank you. So the square root of 3. And then I got square root of 3c2 cosine of, again, pi over the square root of 3. Okie dokes. Now, don't do that yet. What do you want to have happen here?
One of the C's cancel.
Yeah, you got to get something to cancel, right? You guys with me on that? So if I got to get something to cancel, I need something with opposite coefficients, right? You see that? So right now my coefficients are cosine of pi over the square root of 3. Have I got one of those in the bottom? Well, almost, right? Is there something with mismatched signs? Oh, the signs have mismatched signs. And they have a sine of the square, sine of this stupid ass not standard angle, and sine of the stupid ass not standard angle. But what's different between them? The c's and the,
There's an extra root on it.
and there's an extra root on this one, right?
Yeah.
Okay, so first things first, let's divide through by the square root of 3 on this one. Okay, with me on that? Okay, so I'm going to take this equation, multiply by 1 over the square root of 3. So I got minus 1 over the square root of 3 is minus c1.
Sine.
Okay, and I'm going to do myself a favor here. I'm going to call this thing A, and I'm going to call this thing B. Oh no, let's be smart. Let's call them C for cosine and S for sine.
C1C.
Whatever. Pick a reasonable variable. I don't care what it is. Don't pick O. So I got minus 1 over the square root of 3 is minus C1 times S plus C2 times this thing that's a cosine. Something. Right? And then my other equation looks like 2 is C1 C hat plus C2 S. Okay, now can you add these together and get something to go away?
No.
Correct. Okay, so what do you need to do?
I don't know.
Oh, come on, you guys could solve this.
Oh, we have to do the coefficient?
Oh,
You could solve for C1 and you could plug it in. That would totally work.
could we say that the sine is a shifted cosine and it's changing to
Yeah, you could dork around with shifting of the sine and cosines. That would kind of work. Another thing you could do is you could just be like, okay, so to get the C1s to cancel, right, they need to have the same coefficient. You see that? So you could divide this whole equation through by S and divide this whole equation through by C1. Oh, sorry, by C. Right? That would get you a C1 and a C1 with opposite signs, and then you could just add them up. Guys cool with that? So, no, we're not cool with that. Multiply by 1 over S, and multiply this one by 1 over C hat. Okay, so I got minus 1 over the square root of 3 times that stupid sine thing is minus C1 plus C2 C hat all over the stupid sine thing.
2 over
So now we have cosecants and cotangents.
Yeah, sure. And then the other equation is 2 over C hat is C1 plus C2S over C hat.
C1's cancel.
And then we can add these together and we get some messy thing.
Super messy.
I really should figure out how that thing works. Shifting thing would be super worth knowing right now, huh? Okay, so let's see. If I add those together, I got minus 1 over the square root of 3 times the sine thing
Plus.
plus 2 over the cosine thing is some C2s. So there's C2s, and the C2s are times a C hat over S plus a S over C hat.
Do some tangent stuff with this, or no?
Yeah, you certainly could notice that that's a, see, cosine over sine is which one? It's cotangent plus tangent.
That one.
Or you could find a common bottom, right? Or you could say, ah, hell with it, that thing's a number. Just divide by it, right? So you get C2 is all this crap, right? So you got minus 1 over the cube root of sine of pi over the square root of 3 plus 2 over the cosine of pi over the square root of 3 all over, let's see, we said that one was a cotangent of pi over the square root of 3 plus tangent of pi over the square root of 3. Okay, so that's what C2 is.
Do you want us to get a numeric value for that, or leave it as that?
Hell no, leave it like this. It's horrible. It'll be even worse if you punch it in your calculator and get it wrong.
That'd be a mess to even get that.
Right? And then take this, plug it into one or the other of those, and run through a similar rigmarole, right? I would probably recommend that you take one of these, like this one, right? And solve for C1 by itself first, right? Before you go to plug this in. So if you solve that for C1, I think you get C1 is 2 over the cosine thing minus C2 sine over cosine thing. So I think you could write what C1 is here. This is just horrible algebra, right?
Yeah.
Like none of this is actually hard, it's just really annoying to do. Okay, so in the end you get C2 as a number, right?
Sure.
Specifically
C1 is
that
right
number,
there for sure.
right? It's that with this plugged into it. Fine, whatever. And then what do you do with that information?
Plug it back
Plug
into
it back
the-
into.
Yeah, that goes back into your original, which looked like, well, it was here a while ago, but it looks like this, except with a Y here, and those are different.
Yeah.
You guys cool with that? Trust you could do that? No, probably
No.
not. Okay.
This is
Algebraically horrible. Yeah, that's okay though.